Okay, so basically, this is a chapter that a lot of students tend to find difficulty in understanding or applying, especially application. Okay, now in this lesson, we're going to talk about how do we look at the effect of the position of the center of gravity on the stability of objects. And now this is one of the lesson objectives that you need to know for your O-levels. Okay, so now in this diagram, you see two objects. Both are made of wood, but the one on the left has actually lead that is attached to it. So first and foremost, let's identify the position of the center of gravity. Now, the center of gravity is the point at which the entire weight seems to be acting on it. So definitely it will gravitate towards the area that has larger mass and therefore larger weight. So if you look at the first object, if you were to indicate the center of gravity, it will definitely be towards the lead. All right, so let's mark it out with a cross. Okay, I will mark it out with the, so it will definitely be somewhere lower. So this is the center of gravity. Now the center of gravity is where the weight appears to act on. So therefore, you don't only just indicate the center of gravity, you need to also indicate the weight. Now the weight is a pulling force that's always pulling objects directly to the center of the earth. All right, so the weight, let's indicate the weight. Okay, so this is the weight of the first object, and the center of gravity is nearer to the ground. Okay, now how about the object on the right? So the object on the right is a regular shape sort of wood. So therefore, the center of gravity would be at the center. So let's draw the center of gravity. Okay, now it should therefore be somewhere in the middle. We use a cross to represent the center of gravity. And again, the center of gravity is the point at which the weight acts upon. So therefore, let's indicate the weight. All right, so again, it is a pulling force that brings that pulls objects to the center of the earth. So again, let's indicate let's label the force. Okay, so as you can see, the object on the left has a center of gravity that's lower to the ground, closer to the ground, and that's only natural because of the lead that is at the bottom. Whereas the object on the right, the center of gravity is higher because of the way the mass is distributed. So maybe I just indicate it by showing you. Can you see that the center of gravity is nearer to the ground on the object on the left, and the center of gravity is higher, further from the ground. All right. Now, how will this affect the stability of objects? Now, just to recall, the test of stability is to actually tilt the object slightly, okay, from its original position, and see if it returns to the original position. All right, let's take a look at what happens to the objects when we tilt it slightly. Now, one more thing that we need to take note of is the line of action of weight or force. Okay, so now let's draw in the line of action. Now, the line of action is actually, maybe I will use another color. I'll use green to represent the line of action. Now, the line of action is actually the line that shows you the direction of the force. All right. Now, this is very essential to help you understand, okay, how it works. So before we look at the stability, now the weight is pulling downwards. So the line in green are actually what we call the line of action of the weight. Okay, let me just shift this to the right a little bit. Okay, so now the length doesn't matter. What you need to know is that this two represents the line of action of the force, in this case, the weight. So let me just indicate it. These are known as a line of action of the weight. Okay, so as we tilt the object, we're going to see whether this line will lie outside or within the base of the two objects. Okay, so let's take, for example, what happens when we tilt object A. So maybe let me just label object A here. This is object A. and this is object B. Okay, so that is easier for you to understand. Okay, so let's see. Let's take a look at the stability of object A. Okay, so I'm going to just draw what happens as we tilt the first object. All right, so when we tilt it slightly, it will look something like that. So pardon the drawing. Okay, now let's draw in the lead portion as well, which is here. Now you realize that as I tilt it, this line of action will always be within the base, right? The center of gravity is over here and the weight is still acting downwards. Let me just shift the weight a little bit. Okay, the weight is still acting downwards. And what you realize is the line of action. Okay, so let's draw in the line of action. Okay, can you see the line of action is still well within the base area of this object now, what is the base area? The line of action, which is in green, the line of action is still well within the base area of the object. Okay, so therefore, if it is well within the base area, we call this stable, which means that once you release it, it's going to turn in an anti-clockwise fashion. Once you release it, it's going to turn back over or turn back to the original position. Why is that so? Because the line of action, the one in green, is still well within the base area. Okay, so let's label this. Therefore, we call this stable equilibrium. So object A has a stable equilibrium. Okay, so this is what happens when the center of gravity is too high. So when you tilt it, right, the line of action will now fall outside the base. Okay, so again, the center of gravity, when object B is being tilted, the center of gravity doesn't change, but because it's higher up, you draw in the weight. This is the weight, but you realize that the line of action of this weight, which is indicated by green, okay, is now outside the base area. Remember, this is the base area. So it has, when the center of gravity is higher, when you tilt the object, the line of action of weight in green will therefore lie outside the base. Now, when this happens, can you see that the weight will actually cause the object to turn in a clockwise fashion, and therefore the object will not return to its original position, but it will fall to the ground. Okay, and therefore this is what is known as unstable equilibrium. Right, so B has unstable equilibrium. So let's summarize. So if you look at object A, so in object A, the center of gravity is lower to the ground due to the presence of the lead. When the center of gravity is lower, when the object is tilted, the line of action will not lie outside the base. Okay, but for object B, because the center of gravity is higher, right, it's higher, and therefore when you tilt B slightly, the line of action of the weight will fall outside the base easily, and this causes it to rotate and fall to the ground. All right, so let's summarize. Okay, object A has stable equilibrium. Let me use another color. Okay, now, so this is something you need to take note of. Object A has a stable equilibrium. Why is that so? Because of the lowered center of gravity. So the lower the center of gravity, what happens is when you tilt it slightly, the line of action of weight will not lie outside the base easily. So when it does not lie outside the base easily, it can prop it back up again. Okay, now object B has an unstable equilibrium. Now, why is that so? Again, when the center of gravity is higher, further from the ground, then when you tilt it slightly, what happens is the line of action of the weight in green will lie outside the base easily, and that will cause it to topple over. Okay, so I hope you have a better understanding of this question. Once again, practice is needed, and as we practice, you will understand this better.